What if I told you there's a leafy green that has been growing wild in your backyard, along roadsides, and in abandoned fields, a plant your grandparents probably knew by name that contains more iron per gram than spinach, more protein than most leafy vegetables, and enough nutritional power to have fed entire civilizations? And what if I told you that modern agriculture almost completely forgot about it? This isn't a new superfood invented in a lab. This isn't something imported from a distant rainforest. This plant has been living right beside us for thousands of years. It grows fast, it comes back on its own, it survives drought, and it costs almost nothing to cultivate. Yet somehow, in the past century, it disappeared from our plates, our farms, and our conversations. The plant is green amaranth. And today, scientists, farmers, and nutritionists are calling its return one of the most important agricultural conversations of our time. Let's talk about what this plant actually is, because most people have walked right past it without ever knowing what they were ignoring. Green amaranth goes by the scientific name Amaranthus viridis, though the broader genus Amaranthus includes over 70 recognized species, many of which share similar nutritional profiles. It belongs to the family Amaranthaceae, the same botanical family that includes quinoa, beets, and Swiss chard. The name amaranth itself comes from the ancient Greek word amaranthos, meaning one that does not wither, a name that turns out to be remarkably accurate, both botanically and historically. In terms of appearance, green amaranth is a broadleaf annual herb that typically grows between 60 centimeters and 1.5 meters tall, depending on the growing conditions. Its leaves are oval to rhombic in shape, bright to dark green, slightly wavy at the edges, and soft to the touch, making them ideal as a cooked green. The stems are upright, sometimes tinged with red or purple near the base. The flowers are small, densely packed, and arranged in slender green spikes called panicles that emerge from both the leaf axils and the terminal end of the stem. These spikes later produce thousands of tiny, lens-shaped seeds that are themselves another extraordinary food source. What makes amaranth genuinely rule-breaking compared to other leafy greens is a combination of factors that almost no other plant can match simultaneously. First, it is a C4 photosynthesis plant, the same efficient photosynthetic pathway used by corn and sugarcane. This means amaranth converts sunlight into energy with exceptional efficiency, allowing it to grow rapidly even in intense heat and full sun. Most leafy greens wilt and bolt in summer heat. Amaranth thrives in it. Second, the plant is what botanists call a facultative weed, meaning it can establish itself without any human assistance whatsoever, yet it responds dramatically to proper cultivation. It can grow in poor, degraded soils where spinach or kale would simply fail. Third, and this is what makes its story so fascinating, this plant was not always forgotten. The Aztec civilization in Mesoamerica cultivated amaranth as one of their three sacred crops, alongside maize and beans. Archaeological records show that amaranth was consumed, traded, and even used in religious ceremonies over 8,000 years ago. In South Asia and sub-Saharan Africa, wild amaranth species have been eaten as everyday cooking greens for generations. So, how did such a powerful, resilient, deeply historical plant end up growing as a weed along the side of the road while we spend money importing iron supplements? One of the most remarkable things about green amaranth is that it doesn't ask much from the land, but it gives back enormously. Understanding where and how this plant grows helps explain both why it thrived for millennia and why farmers today are rediscovering it as a resilient, low-input crop. Climate and growing conditions. Green amaranth is classified as a warm season crop that performs best in temperatures between 21 degrees Celsius and 35 degrees Celsius, 70 degrees Fahrenheit, 95 degrees Fahrenheit. Unlike cool season greens such as spinach or lettuce, amaranth does not bolt prematurely in heat. In fact, heat accelerates its growth. It requires full sunlight for at least 6 to 8 hours per day and is moderately drought tolerant once established, thanks in part to its C4 metabolic pathway that reduces water loss during photosynthesis. Regarding soil, amaranth is uniquely adaptable. It grows in sandy loam, clay loam, and even degraded soils with a pH range of 5.5 to 7.5. It is not frost tolerant and should only be planted after the last frost date in temperate regions. Waterlogged or heavily compacted soils will restrict growth, but almost any well-drained soil with moderate fertility is sufficient. This makes amaranth one of the very few nutritionally dense crops that can grow on marginal land that might otherwise produce nothing commercially viable. Where it grows most abundantly. Green amaranth, Amaranthus viridis specifically, is found across tropical and subtropical zones worldwide. Its primary growth regions include India, where amaranth leaves, locally known as cholai or thotakura, are consumed as a daily cooking green across states like Andhra Pradesh, Telangana, Maharashtra, and Kerala. India is one of the largest producers of amaranth leaves for domestic consumption. West and East Africa, particularly in Nigeria, Ghana, Kenya, and Ethiopia, where amaranth leaves are a critical dietary green, often called alepho, inine, or mchicha in various local languages. Central and South America, especially Mexico, Peru, and Guatemala, where the grain varieties of amaranth, Amaranthus hypochondriacus, and Amaranthus cruentus, are cultivated at scale for both grain and leaf production. Southeast Asia, including Indonesia, the Philippines, and Vietnam, where amaranth is a common market vegetable. China, where amaranth is cultivated in southern provinces and is also used in traditional medicine. In terms of global grain production, Peru, Bolivia, and Mexico lead in amaranth grain cultivation. The United States and Europe are growing markets, with organic amaranth grain and flour becoming increasingly available in health food sectors. Growth timeline, seed to harvest. Amaranth is one of the fastest establishing leafy crops available to any farmer or home gardener. Here is the real timeline. Days 1 to 4. Seeds germinate rapidly when soil temperature exceeds 18 degrees Celsius. Seeds should be surface sown or planted no deeper than 6 mm because they need light to germinate optimally. Days 5 to 15. Seedlings establish their first true leaves. At this stage, thinning is important. Plants should be spaced at least 20 to 30 centimeters apart for leaf production, or 45-60 centimeters apart if grain production is the goal. Days 20 to 40. Plants enter rapid vegetative growth. Leaf harvesting can begin as early as 25-30 days after germination by removing outer leaves, which actually encourages further branching and continued production. Days 50 to 70. Plants begin forming flower spikes. At this stage, if you are growing for continued leaf yield, pinching the central spike delays seeding and extends the leafy harvest. Days 90 to 130, full maturity for grain harvest. The panicles dry out and seeds can be threshed. A single mature amaranth plant can produce 40,000 to 60,000 seeds, which are themselves a high-protein, gluten-free grain. Farming and home-growing notes. Amaranth requires minimal irrigation once established and responds very well to a single application of nitrogen-rich compost early in vegetative growth. It can be grown successfully in containers of at least 30 centimeters depth, in raised beds, in small kitchen gardens, or at commercial scale. No specialized equipment is needed for leaf production. This accessibility is precisely what makes it valuable for smallholder farmers, urban gardeners, and food-insecure communities alike. When we talk about the nutritional profile of green amaranth leaves, we are not talking about marginal benefits or minor improvements over other vegetables. We are talking about a plant with a nutritional density that rivals or exceeds many commonly recommended vegetables, including spinach, the gold standard of leafy greens in popular culture. Iron content, the core claim, verified. Raw amaranth leaves contain approximately 3.0 to 3.9 milligrams of iron per 100 grams of fresh weight, depending on the variety and growing conditions. For comparison, Raw spinach contains approximately 2.7 milligrams per 100 grams. Cooked amaranth leaves, due to moisture loss during cooking, show even higher concentrations per gram. This is not a marketing claim. It is documented in nutritional databases, including the USDA Food Data Central, and various peer-reviewed studies published in journals such as the Journal of Food Composition and Analysis. Iron in amaranth is non-heme iron, which is enhanced in absorption when consumed alongside vitamin C. And conveniently, amaranth leaves are also a natural source of vitamin C. Full nutritional profile: per 100 grams of fresh amaranth leaves, you receive protein 2.5 3.5 g, exceptionally high for a leafy vegetable. Calcium 215 267 milligrams, critical for bone health, higher than most common greens. Vitamin A, as beta-carotene, 1,140 2,917 micrograms, essential for eye health and immune function. Vitamin C, 43 to 80 milligrams, supports iron absorption and immune defense. Folate, 85 to 100 micrograms, vital for cell division and especially important during pregnancy. Magnesium, potassium, and phosphorus in meaningful bioavailable quantities. Dietary fiber, supporting digestive health and gut microbiome diversity. Amaranth also contains squalene, a natural lipid compound found in the seed oil that has been studied for its antioxidant, anti-inflammatory, and potential cholesterol-reducing properties. Research published in Lipids in Health and Disease has highlighted squalene's role in cardiovascular protection, medicinal and clinical applications. In traditional medicine systems across India, Africa, and Latin America, amaranth has been used for centuries to treat conditions including anemia, constipation, respiratory infections, and inflammation. Modern research is beginning to validate some of these traditional applications. Studies indicate that amaranth leaf extracts demonstrate antimicrobial activity against certain pathogenic bacteria, and the plant's polyphenol content gives it documented antioxidant capacity comparable to well-known medicinal herbs. For individuals at risk of iron deficiency anemia, the most common nutritional deficiency globally, affecting over 1.6 billion people according to the World Health Organization, regular consumption of amaranth leaves represents a genuinely practical dietary intervention, especially in regions where red meat and fortified foods are economically inaccessible. Benefits for animals: amaranth biomass, including the leaves, stems, and residual plant matter after grain harvest, is a viable and nutritious component of livestock and poultry feed. Research trials in Africa and South Asia have demonstrated that including amaranth foliage in goat and cattle diets improves weight gain and provides supplementary protein during dry seasons when pasture quality declines. In poultry nutrition studies, amaranth leaf meal has been tested as a partial replacement for conventional protein supplements, with positive outcomes in egg production and bird health. Environmental benefits: amaranth offers meaningful environmental contributions that are increasingly relevant in the context of climate adaptation. Its deep taproot system improves soil aeration and helps break compacted soil layers, benefiting subsequent crops. As a fast-growing, high-biomass plant, it contributes organic matter back to the soil when incorporated as green manure. Amaranth flowers are also significant pollinator attractors, supporting bees and other beneficial insects. Because it can grow in degraded and drought-affected soils, it plays a role in land rehabilitation in food-insecure regions. Here is something worth sitting with for a moment. We live in an era where iron supplements are sold by the billions. Anemia affects 1 in 5 people globally, and food insecurity is rising in both rural and urban areas, and growing quietly in vacant lots, along fence lines, and in the edges of fields around the world is a plant that produces in 25 days, needs almost no irrigation, grows in poor soil, returns year after year by self-seeding, and contains more iron, more calcium, and more protein per cup than most vegetables you will find in any grocery store. That is not a coincidence. That is an opportunity. If you have never grown a vegetable in your life, amaranth is where you should start. The seeds are small but forgiving. You scatter them on prepared soil, press them in lightly, water gently, and within a week you will see them emerge. Within a month, you will be harvesting. It requires no greenhouse, no specialized fertilizer, no complex irrigation system, a container on a balcony, a raised bed in a courtyard, a small corner of a garden. Any of these is enough to grow a meaningful supply of one of the most nutritious leafy greens on Earth. Why seed preservation matters. One of the most urgent agricultural conversations happening right now is about seed sovereignty, the ability of farmers and communities to save, replant, and share the seeds of their own crops without dependence on commercial supply chains. Amaranth is a model plant for this principle. A single mature plant produces tens of thousands of seeds. Those seeds remain viable for 3 to 5 years when stored in a cool, dry, dark environment. Saving amaranth seeds costs nothing and guarantees food security for multiple growing seasons from a single plant. In a world where commercial seed markets increasingly favor hybrid and patented varieties, maintaining populations of open-pollinated heritage crops like amaranth is an act of agricultural resilience. Indigenous communities in Mexico and Peru have maintained amaranth seed lines for hundreds of generations. That knowledge and those seeds must not disappear. The economic case for farmers, amaranth represents a low-risk, high-return crop option. In urban and peri-urban markets across Africa and South Asia, fresh amaranth leaves command consistent prices in local food markets because demand is steady year-round. The short growing cycle means multiple harvests per season are possible. In warm climates, up to 4 to 6 cuts per year from a single planting. Grain amaranth, increasingly sought by the organic health food industry in North America and Europe, sells at premium prices that rival quinoa in some specialty markets. The global amaranth market was valued at over $400 million in recent years and is projected to continue growing as consumer awareness of ancient grains and nutrient-dense foods expands. For farmers dealing with the compounding pressures of climate change, shorter rainy seasons, longer dry periods, more unpredictable weather, amaranth's drought tolerance and fast cycle time offer something that many conventional crops simply cannot: reliability under stress. The bigger picture, there is a reason civilizations from the Aztecs to the traditional farmers of rural India and East Africa placed amaranth at the center of their food systems. They understood, through centuries of lived experience, that this plant was different. It fed communities during difficult seasons. It kept children from going anemic. It rebuilt soil and fed animals. It came back every year without asking for much in return. Modern agriculture, in its pursuit of high-yield commodity crops, sidelined that wisdom. But the science is catching up to what traditional farmers always knew. And the conversation about food security, climate-resilient crops, and nutritional accessibility in the 21st century is increasingly pointing back to plants exactly like this one. Amaranth did not die out. It was just waiting. If this video has shown you something genuinely new today, if it has made you look at an ordinary weed with different eyes, then take one simple action. Find some amaranth seeds, plant them somewhere, watch what happens in 30 days. And when you harvest those first leaves, rich in iron, calcium, and protein, grown by your own hands from nearly nothing, you will understand exactly why ancient civilizations considered this plant sacred. If you found this valuable, share it with someone who grows food, cooks food, or cares about where their food comes from. Subscribe for more research-backed deep dives into the plants that built human civilization and the ones that can help sustain it. The soil remembers what we forget. It is time we remembered too.